Bowing to pressure from whistleblowers, pilots' unions, aviation safety advocates, and State Senator Tammy Duckworth from Illinois, the chair of the Aviation Safety Subcommittee of the Senate Committee on Commerce, Science, and Transportation, Boeing has decided to delay certification on the last two models of 737 MAX aircraft that they want to certify. The -7 model, shown here, the shortest version of the MAX, and the -10 model, the longest version of the MAX. And the reason for the delay in certification is this engine anti-ice problem that affects the entire 737 MAX series of aircraft and is currently subject of an FAA Airworthiness Directive. Let's check it out. The entire 737 MAX series of aircraft are all powered by the CFM LEAP 1B series of engine. This latest generation of engine uses the latest in technology and material science to get the best emissions and best fuel efficiencies possible out of these engines. In order to do that, they've got to push the technology of material science to use the lightest material they can find and subject these new materials to the highest temperatures and higher pressures than ever seen before inside of these jet engines. And so to that end, to meet the requirements to use the lightest material possible, CFM has changed the composition of the layers of the inner barrel, this section here right behind the nose lip, what I used to call the the acoustic liner on these engines. The first layer has been changed to CFRP. Instead of using a metal alloy, it is now a carbon fiber reinforced polymer design. Now, the second layer is still Nomex, and that's what helps with the acoustics, or keeps the noise down on the engine. And then the inner layer is a corrosion-resistant steel mesh. In order to fly in icing conditions, these engines need to be heated using engine bleed air, usually drawn from the 5th and 9th stage of the compressor, and that air moved through the nose lip of the engine nacelle, through the inside of this nose lip. This heats up this area and melts the ice before it can form onto the blades of the engine. In order to remain in compliance with previous versions of the 737 type certificate on the MAX aircraft, the engine anti-ice is actuated just like earlier models of the 737 with some small differences. And here on Chris Brady's technical site, you can see the engine anti-ice switches down here in the lower right-hand corner. That's how you turn the engine anti-ice on and off. Note there is no automatic position for the engine anti-ice, as is found on more modern designs. Now, when you put the engine anti-ice on, it's taking that extremely hot compressed air from the compressor section, hotter than in years past because these engines are running so efficiently, and it's pumping that hot air into the nose ring here, and it's heating up, and operationally, they're finding that they've found problems with this CFRP, the carbon fiber reinforced polymer layer of the inner barrel. That section that used to be a metal alloy that could handle the heat of the bleed air. Based on recent service difficulty reports on the newly redesigned inner liner, the FAA has issued this Airworthiness Directive affecting all of the existing and currently flying 737 MAX aircraft. Now, the scary part of this Airworthiness Directive is that in the eyes of the FAA and other industry experts, if that inner barrel does fail because of this engine anti-icing overheating it, that can cause a catastrophic failure of the engine. Operating the engine anti-ice in dry air for more than 5 minutes under certain environmental operational conditions can cause overheating of the inner barrel beyond the design limit, resulting in the failure of the engine inlet inner barrel and severe engine inlet cowl damage. If not addressed, this could result in departure of the inlet and potential fan cowl failure and departure from the airplane. The departure of the inlet may cause fuselage and/or window damage, potentially resulting in decompression and hazard to window-seated passengers after the wing, and/or impact damage to the wing, flight control surfaces, and empennage, which could result in loss of control of the entire aircraft. And this is a result of the history that we've seen recently in a couple of other engine cowling failures. Remember back in 2018 when Southwest Flight 1380 had a fan blade event right here, which caused massive destruction of the cowling, which caused a section of the cowling to hit the window and kill one passenger as a result of the explosive depressurization. And remember the destruction of the cowling in Captain Chris Benham's Flight 1175 going into Honolulu when a fan blade out event here destroyed his cowling and rendered the aircraft almost unflyable. Remember, in years past, the cowling was designed to handle a fan blade out event by having that Kevlar reinforced band around the fan to contain the fan blades to prevent them from departing the cowling, but there was no requirement for the rest of the cowling to be able to withstand this sort of punishment. And now the FAA is working on design requirements to require these cowlings to be able to handle this sort of punishment without the cowling itself flying to pieces. As a result of this AD, there's a new limitation in the airplane flight manual for these 737 MAX aircraft. Engines, anti-ice system. Do not operate engine anti-ice in flight when not in actual or anticipated icing conditions. Caution. Operation of the engine anti-ice when not in actual or anticipated icing conditions may result in severe engine inlet damage or failure. So according to Boeing, engine anti-ice must be on anytime you are operating or anticipate to be operating in icing conditions. So what's the Boeing definition of icing conditions? In flight, anytime the temperature is 10 degrees Celsius or less and you have visible moisture in any form such as clouds, fog, visibility of 1 mile or less, rain, snow, sleet, and ice crystals. Well, how can I comply with the one requirement to turn it on if I anticipate icing conditions when I'm now not supposed to turn it on when I'm not in icing conditions? And also, if I'm flying in and out of icing conditions, I've got to sit there and turn this switch on and off all the time. And besides, there's no light in the aircraft in the 737 MAX to tell you when you're in icing conditions. It's all based on the pilot's visual cues looking outside the aircraft plus that temperature of 10 degrees Celsius. In past designs, if you left the engine anti-ice on and you came out of the clouds, it wasn't a problem because the engine could handle that heat. The inner liner, the alloy metal of the inner liner could handle that heat. But now it's a problem, and you've got to remember to turn the engine anti-ice off every time you get out of the clouds. And in my opinion, this could have all been alleviated had, once again, Boeing started with a clean sheet design with a new type certificate and 2 new type certificate rating and implemented a more modern approach to this. They've got the ice detecting capability on the side of the aircraft. They could have wired that up to the anti-ice system, and just like on the Boeing 777, automatically turned on and off the engine anti-ice as required. This Airworthiness Directive also affects the minimum equipment list. Remember that separate document that tells you exactly what equipment you can operate with and without. In this case, you can no longer dispatch the aircraft if one of the engine cowl anti-ice valves is in op. Which brings up the question, and these valves stick from time to time. It's like you got to get the end of a screwdriver out there and tap the valve to get it to unstick, but you can't do that in the middle of a flight. So if you got a valve that's stuck open in flight and you're leaving icing conditions, are you to have to shut down that entire engine, declare the emergency, and come in on one engine just because this stupid valve doesn't close because the design of the engine can't handle the heat from the bleed air? That's not addressed in this Airworthiness Directive. Now, because everybody became aware of this problem after the aircraft was produced and up and running and flying, the Airworthiness Directive was created to address the problem, and Boeing is working on a solution. In the meantime, Boeing was quietly trying to continue to push ahead the certification of the 7 and 10 series of aircraft with this known defect with something called a TLE, or time limited exception, to the FAA. But now, thanks to everybody pushing back on this, Boeing has backed down and has decided to halt the certification of the Dash 7 and Dash 10 aircraft until they get this anti-ice situation sorted out on these aircraft before they begin to continue the certification process for these last two 737 MAX aircraft. And get this anti-ice system fixed for our air crews so they don't gotta have to sit there and continually worry about turning this anti-ice system on and off as they enter and exit icing conditions. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.